In this final chapter, we will take a look at integrals. Integrals, which are also sometimes called the antiderivatives, are the inverse function of a derivative. Since we know the formulas for derivatives, we can also find basic integral functions. For a function f of x, the integral is denoted as follows. So for an integral, it's a long s, so the integral of f of x dx. Assume that my function f of x is x to the power n. Then what is the integral of this function? The integral of this function will be x to the power n plus 1 divided by n plus 1. Now why is this? Let's take a look at the following example. Let's say that my function x to the power n is x to the power 3 over 2. I then want to calculate the integral of this function. So I calculate the integral of this function, which would be, according to the formula, x to the power n plus 1. So it's x to the power 3 over 2 plus 1, which is 5 over 2, divided by 5 over 2. Why does this hold? Well, just take a look at the derivative of the right-hand side. So let's say we have x 5 over 2 divided by 5 over 2, and we take the derivative of this function. From the calculation rules for derivatives, we know that we can take the constant out. So this is 1 divided by 5 over 2 times the derivative x to the power 5 over 2. And then this derivative is just 5 divided by 2 times x to the power 5 over 2 minus 1, so it's 3 over 2. So we see that if we work this out, this is x to the power 3 over 2. So the formula holds because we know, or we defined, an integral as being the inverse of a derivative. So when we take the derivative of my integral, I find back my original function x to the power 3 over 2. However, an integral is not unique. Why is it not unique? Because we know that the derivative of a constant is equal to 0. So actually, the integral of this function is not x to the power n plus 1 divided by n plus 1, but is this plus any possible constant. So c is just a constant. C is some real number. Why? Because if I plug this in, my formula becomes here x to the power 5 over 2 over 5 over 2 plus a constant. And if I then derive this, it is just the same thing because the derivative of my constant is just 0. So an integral is not unique. It is only defined up to a constant. So for any constant, we can add any constant to the final solution. And in the same way, we can find the following list of formulas using the formulas we know for the derivative. These formulas hold because we know the formulas for the derivative. For example, if we take here, if the integral is sine x plus c, then we know that the original function has to be cosine of x. Why? Because the derivative of sine x plus c, this is equal to the cosine of x. We can also add boundaries to the integral. So if we add boundaries, to the integral, in that case, the integral is called a definite integral. And it is written just as an integral, so the integral of f of x dx, but between the boundaries a and b. So we have a lower boundary a and an upper boundary b. This means that we calculate the integral over an interval instead of over the whole real line. So we calculate the integral over the interval ab instead of over the whole real line, so over all the values in R. For naming, so this, the long-shaped S, is called the integral sign. So the integral sign is basically a long-stretched S, the letter S, because an integral is defined as an infinite sum. So because it is a sum, we indicate it with a long stretched s. Then you have a and b. A and b are called the limits of integration. So they define the upper and the lower boundary of your integration. The function f is called the integrand. And then x is the variable of integration. And then finally you have d of x. D of x is the differential of x. So the differential of x will mean or will indicate that we take an integral with respect to the variable x. In this part of the course we will have only one variable of integration, x, and as such we can only take a differential to this variable x. Later on you will also see functions with two variables, x and y, and then d of x will mean that you take an integral with respect to x, d of y will indicate that you have to take the integral with respect to y. Please also note that the variable of integration is just a variable. So if I have an integral a to b f of x dx, I can just as well write this as a to b f of t dt. It is just a letter which we use to indicate the variable, but it really doesn't matter which letter we are using. So it's just a dummy variable. We can use any letter that we like, as long as we are consistent with f of x, d of x, f of t, d of t. So it has to be the same letter, the same variable for the function and the differential. How can we then calculate a definite integral? Let us first introduce some notation. So write the integral of f of x dx as being capital F of x plus a constant. So this capital F of x is called an antiderivative. Of small f of x. So it's an antiderivative because there are infinitely many of those capital F because of the constant which can define another capital F. So we see that for this it holds that f prime, so the derivative of capital F, will be equal to small f of x. In that case, we can calculate the derivative of f of x dx between the boundaries a and b as the antiderivative in b minus the antiderivative in a for any antiderivative. So it doesn't matter which antiderivative we take. So for any f such that the derivative of f, capital F, is equal to small f. So to calculate a definite integral, what we need is one of the antiderivatives. It's not important which one. And now we take this antiderivative in the upper boundary minus the antiderivative in the lower boundary. Clearly, the constant is not important. Because the constant cancels out in the subtraction anyway. We also see that the formula is the value of capital F in the upper boundary minus a value of capital F in the lower boundary. So a definite integral is always a value. So it's a value, not a function. So if you are asked to calculate a definite integral, your answer always has to be a value. It can never be a function. And then there's one final notation. So we have f of b minus f of a. In short, we write this as f being evaluated between a and b. So this line with a and b, this is called the evaluation sign, or the evaluation symbol. And this evaluation symbol just means that you first plug in the upper value, so in this case b, and then you subtract from that the function in the lower value in a. And then finally, there's one important remark. Suppose that I have a definite integral with a lower boundary a, but my upper boundary is not a value, but a variable x. So we have an integral of a function f of t dt. So we have a random letter here, the letter t, as the variable of integration. Why do we take t? Because we already use x, the variable x, in the upper boundary of the integral. If I then take the derivative, 2x, so d dx of this integral where x is also in the upper boundary, then this is equal to f of x. So here we do have a function, but our answer here is a function because the upper boundary in my integral, this is not a value, but it's a variable. So it is not a fixed value, but a variable x. And so if this is the variable, then here the answer is a function instead of a value. Let us then apply the formula for the definite integral to some examples. For the first one, take the integral between 0 and a of the function x squared dx. And then the second integral, take the integral of x squared minus 3x plus 2 dx between the values minus 1 and 2. So what you have to do is first calculate the integral, the indefinite integral, so the integral without any boundaries, and then plug in the boundaries. So for x squared, this is x to the power 3 divided by 3 plus a constant, but this constant does not matter because we have a definite integral, and then we evaluate this between 0 and a. So a in this case is just an unknown value, but it is a real number. We first plug in a, it's the upper boundary, so it's a to the power 3 divided by 3 minus the evaluation in the lower boundary, 0 to the power 3 divided by 3. So my final answer here is a to the power 3 minus 3. For the other one, we do the same thing. So we have our integrand, so this function which we have to integrate. We do the integration, so this is x to the power 3 divided by 3 minus 3 times x to the power 2 divided by 2 plus 2 times x. And then this function is evaluated between minus 1 and 2. We plug in 2, so it's 8 over 3 minus 3 times 4 over 2 plus 2 times 2 minus the same thing in the lower boundary, so in minus 1. So it's minus 1 to the power 3 divided by 3 minus 3 times 1 divided by 2 plus 2 times minus 1. And then if you calculate this, you get 6 minus 36 plus 24 plus 2 plus 9 plus 12 divided by 6, or you get 27 over 6, which is equal to 9 over 2. So the value for this definite integral, the final solution for this definite integral is 9 over 2.